Hello there. This module is dedicated to the Kohn-Sham equations. It is a very good example, if not the prototype, of the auxiliary system idea we have seen previously. We will introduce this auxiliary system and the respective equations in a multiple steps approach. Let's start by getting our original problem, the minimization of a density functional to find the minimum that would give us the ground state total energy. We know that if this functional exists, it is unique, but its ingredients are unknown. In particular, we do not know neither the kinetic energy functional nor the interaction term, the electron-electron energy functional of the density. Now the question is, can the concept of auxiliary systems help? In particular, the auxiliary system of non-interacting particles? Or, which is somehow related, can old ideas that are essentially based on variational formalism also help? We will see that it is possible to exploit those ideas and much of the old approaches to obtain useful insights about those unknown functionals. This is actually done by devising a new term, a new energy functional term that is supposed to be easier to deal with. And this is the precise scope of this video, to define a new functional of the density, taking older approach as inspiration. So the point here is that the idea of using auxiliary systems, especially in the independent particle system, was a very successful one, even though in an approximated level. We have seen this in the historical overview last week. One way to approximate the exact full energy functional of the density, which is unknown, is to consider the Thomas Fermi energy functional. In the Thomas Fermi approach, the unknown kinetic energy functional is approximated by a simple power of the density, while the electron-electron contribution is also a simple functional of the density. Can you recognize this term? Exactly. It is the very same we find in the Hartree theory, for which again the kinetic and electron-electron terms are approximated. And in fact, the Hartree equations derived by the Hartree total energy functional are independent particle equations. Can we use the very same ideas, the Hartree approach, which is an independent particle system and carries a simple interaction term, can we get inspiration from this for the exact energy function? As you can already guess, the answer is yes. And here is how we use all these concepts. We start from the generic exact energy functional of the density, the usual functional in which the unknown terms constitute the universal functional, or the Oeyenberg-Kohn functional. We start now making some very simple manipulations. Firstly, we add and subtract the same quantity, that is the kinetic energy functional of an independent particle system of density n. Now again, we add and subtract the same quantity, the equivalent of the electron-electron energy term within the Hartree approximation. So this is still the very same unknown energy functional, but let's now reorder the terms. We collect first the kinetic energy functional of an independent particle system, ds. Then we take the contribution due to the external potential and the electron-electron Hartree contributions. You might notice that so far we have collected only terms that are very easy to write down. Let's finish by taking the unknown universal functional. You can see what's left here, the two negative contributions. We collect them as well. So with this reordering, that hasn't changed at all the value of the total energy, because we just added and subtracted the same quantity. With this reordering, we can read the total energy as a sum of the total energy given within the Hartree approximation plus the rest. And let's call this extra term the exchange and correlation energy functional. It seems just a reordering, but the fact of explicitly taking everything we know, kinetic term of non-interacting particles, external potential, Hartree energies, out of the universal functional, we are now left with a hopefully smaller quantity that can be expressed as energy difference. It is in fact the sum of the difference between the functional of the real kinetic term minus the kinetic term of the non-interacting particles. This will certainly be smaller than the full unknown functional of the kinetic operator. And second, the difference between the exact electron-electron interaction and its equivalent in the Hartree approximation. Again, given that this is already a more than decent approximation, this energy difference will be smaller than the full exact value. Let's wrap up what we have done so far. We managed to rewrite the total energy functional in such a way that instead of having to approximate two complicated functionals, like here T and E electron-electron, we can try to focus on a smaller quantity, the exchange and correlation energy. We managed to do that by taking inspiration from old approaches, like Hartree. But you might remember that one of the most important points of the Hartree approach, or Hartree-Fock, is to give us one-particle equations. So in the next video, we'll see how to push forward this reasoning of non-interacting auxiliary system to obtain one-particle equations. And for the moment, I say goodbye.